Hey guys, welcome to my tutorial on conditional expressions. Conditionals allow you to define control flow for your program. The most common form of a conditional that you'll see in many other programming languages are if expressions, and they're generally defined with the following syntax. If some Boolean expression, then some other expression that returns a value val1, else some other expression that returns a value val2. Which of these two values, val1 or val2, gets returned depends on the result of the Boolean expression. So if the Boolean expression is true, it'll return val1. If it's false, it'll return val2. Let's work through a little example. Let's create a function here, and it's going to take an input, power level. And we're going to say if power level is less than 9,000. Okay, so this will be our Boolean expression here. So this is going to return either a true or false value. If we didn't put a Boolean expression here, like let's say we just put 9,000 here, this would be an error. We can't do this. So we need to return some sort of Boolean expression inside this level. Okay, if it is less than 9,000, then we'll return some expression. So let's just return a string here, lame. Else, if it is over 9,000, well, it's over 9,000. Need a number of exclamation marks here. Okay, and the type of this function, ignoring the default type that it's trying to give us here, which is a bit more complicated than it needs to be, is going to be the dialog. Let's say power level is an integer, that's suitable. So we're comparing it to 9,000. Okay, so that'll be suitable, saying it's an integer itself, and it's going to return a string. An interesting thing we can do with conditionals is nest them inside of one another. So this allows us to create multiple layers of control flow. So take, for example, the function signum, which returns -1 if the int given to it is a negative number, 0 if the int is 0, and 1 if the int given to it is a positive number. So usually just a standard if can test one condition, and then on that condition give two different possible answers. Okay, so you'll notice that in order for signum to work, there's three different possible answers, three different scenarios that it can return here. So we're going to need a extra if inside of the initial condition. So we'll start off by testing, is it smaller than 0? If it is, then it's -1 off the bat. Okay, then we can just forget about everything else. If it isn't smaller than 0, then we have to have an else here, and then this else is a whole nother conditional expression. Okay, so this is, you could consider this whole expression that I've highlighted here to be wrapped in brackets. Okay, so this is a whole nother expression that gets evaluated, and then it tests, is n equal to 0? Okay, if it is equal to 0, we return 0, else we return our final expression. It is important to note when writing if expressions, indentation is important. I brought this up last tutorial, but just a quick reminder. You could write the whole if expression on one line, so you could just write everything as on one line and say if n small equals 0, then -1, else n equals 0, then 0, else 1. Okay, but this starts to look pretty messy, and actually I made a little error here, so you'll see it even notices it right away. It says parse error. So parse error is like, something's not right here. Just right off the bat, it's not going to compile. So you'll notice I'm missing in my else here, if. There we go. Okay, and so I could write this all on one line, but it doesn't look very good, right? Usually when I write an if expression, I'll say if, I'll write my conditional, okay, my Boolean expression there, and then I'll start a new line, and I'll indent inside of the if. So I'll indent a bit further in, and then I'll write my then, okay? So if it's smaller or equals 0, then -1, and then I'll make a new line again, and you have to make sure these line up, the then and the else line up here. Okay, make sure they're on the same line here. And you're gonna have to be careful if you're mixing spaces or tabs, okay, back to the spaces versus tabs debate. Okay, if everything is always spaces all the time, you won't run into some issue here. On the else here, now I could write my next if expression. I'm going to do the same thing, where I'm going to say, okay, else if n is equal to 0, then, okay, so now this then now has to be indented from this if. You have to keep track of which then belongs to which if, okay? So then 0, else 1. So this is all one expression here. And this is all one sub-expression to this expression. So I can actually put brackets around this thing, just to be ultra specific about what's going on here. Okay, so with or without the brackets, the same sort of precedence that's happening. Okay, but the brackets just emphasize what is happening here. So this is all one sub-expression that is the expression that gets returned by the else. The same way this -1 is the expression that gets returned by the then. Now, a note on if expressions. In Haskell, if expressions are just that, expressions. So what does this mean? So every expression is going to have a type. So the idea here is, if you think about expressions as like the expressions you're probably used to from math, they all kind of evaluate to one value, okay? And that value is going to have a type at the end of the day. So an if expression, it's going to evaluate to one value at some point, and that value is going to have a type. So let's take a look at our functions here. So let's go back to our function. So this DBZ dialog, it returns a string. Okay, so this is relying on the fact that this if expression, it's going to evaluate to a value. Okay, just like how 1 + 1 - 2, any math expression, eventually it's going to evaluate to one value. Okay, in this instance, that would evaluate to 0, right? And so this is going to evaluate to one value, okay, at some point. There is a control flow here, so there's a decision on exactly what that value is going to be. But when it does evaluate to that value, whatever that value is, that it's going to have type string. So if I were to switch this up and say, well, if it's under 9,000, then I return 0. This is a type error, okay? Because now we have one situation where this function returns an int, and another situation where this function returns a string. This can't be. This function has to return one type. Okay, so we can't just switch things up willy-nilly, returning one type at one time and another type at another time. Same with signum here. Okay, so if we add the less complicated type than what VS Code is suggesting, we could say, well, signum takes an int and returns another int. Okay, so I can't magically say, well, if this is less than 0, then we return it's negative. We return a string here. Okay, this is also a type error. Okay, and we can put our mouse over this. So see how it's underlined red? If you put your mouse over it, this will appear, and it'll tell you the type error. So it's the general couldn't match expected type. So it was expecting an int, but it got a char. Okay. The one exception to what I just discussed is partial functions. So basically, anytime, instead of returning a value, you can consider this a special value called undefined. So at any point in time, instead of returning a value of a specific type, you would just say undefined. And what actually happens is when Haskell is evaluating stuff and it runs into this value, undefined, it just crashes. Whenever it reaches undefined, the program will just crash. Now, undefined is actually available, so you could just write undefined in your code, but it's better to use the error function, which is the exact same thing as undefined. However, it outputs a specific error instead of just saying reached undefined. So as an example, let's say when power level is less than 9,000, instead of returning a string, we just write undefined. So we just let our program crash, okay? So if the power level is not greater or equal to 9,000, then there's no point in this, okay? We should just crash, the program should just die. So if we load this into GHCI to test it out, and we call DBZ dialog 8,000. Okay, you see you get exception, prelude, undefined. Now, this isn't very good. This is why we should never, ever write just write undefined, because let's say you're trying to fix your program and you're trying to find out like, oh, where did this happen? And you have multiple undefineds written all throughout your program, it's going to be very, very difficult to figure out what is going on. So what you should do instead is you should use the error function, and the error function takes a string, and this string will get outputted instead of just as prelude.undefined. So never use undefined, always use this error function, and you could write something like, this program is too lame to keep running. Okay, it should be a specific error message to what's going on so that it's easy to track down. So now if we reload this into GHCI, okay, make sure your file is saved first and reload. And then we run this again. See, now it says exception, and it gives whatever I put in that string here. As an alternative to if expressions, we can use guarded equations. So this has a syntax that uses this vertical bar before you define the function. So usually we write something like, our function is equal to this expression. And at that point, we might write if something, something, then this, else this. With guarded equations, what we do is we say our function, and then we write these guards, okay, these vertical bars, and we put our Boolean expressions, and we say what our function is equal to, what the definition of our function is equal to, based on these Boolean expressions here, okay? And you have a default Boolean expression here, otherwise. Otherwise always evaluates to true. So you should always put it, whenever you have a series of guarded expressions, otherwise should always be the last thing here. Now, a note about guarded equations is there's never really a reason that you would have to use them instead of an if expression. They're completely interchangeable. It just looks nicer. It's just sometimes a nicer way to write out your code. So let's go back to our code here, and let's try and create an improved version of our signum function called signum2. And this is actually going to be the exact same function. It's not going to be improved in any way, except that it's going to be more readable. So instead of just saying equals here, what we're going to do is we're going to put a new line, indent, and put our vertical bar, and we'll test our first condition of is n smaller than 0. And if it is smaller than 0, then what the function is going to be equal to is -1. New line, make sure this lines up, vertical bar, they should both line up, indentation matters, n is equal to 0. Okay, this is our second condition. And if it is equal to 0, then the function is going to be equal to 0. And then the third scenario is going to be if n is bigger than 0. But a better way to do this, to make sure that we cover every single scenario, is just to write otherwise, which is actually the same thing as just writing true. But otherwise is a bit more readable. It's just kind of nice to read. So otherwise equals 1. And comparing these two functions, you'll see they're the same thing. They'll work the same way, but this function is a decent bit more readable than this function. Another construct that could be used as a conditional, although this one is actually far more powerful than just conditionals, is pattern matching. So pattern matching allows you to write values in place of where you would usually just put your parameter, so your argument variable. You actually write the real value there, and then you make multiple definitions of the function. So consider not as an example. Not takes a parameter, a Boolean parameter, we call it x, okay? And if x is true, then it returns false. Otherwise, it returns true. So it's kind of returning the opposite of whatever its input is. So this is one way we could have written not. We could write it another way with guards. Or we could write it a third way with pattern matching. So the idea with pattern matching is instead of writing x here and then the function definition, we would write the value that we're matching x to and then the function definition. And then we just keep defining the function again with the value we want to match to. So we have, in this sense, we have like multiple definitions of our function based on the value of its input. You go about pattern matching in a variety of different ways. Consider the AND function. So a logical AND returns true if and only if both of its inputs are true. So it takes two inputs and you're basically saying this and this. So only if both things are true is this going to return true. So we go about defining this by writing out every single scenario for both inputs and pattern match on them. Okay, so we end up, because there's two inputs and each of those inputs can have two separate values, there's going to be 4 different scenarios here. Now, the nicer way we could write the AND function is we'll pattern match on the first argument, and we'll pattern match to true, and then for the second argument, we'll leave it as a variable. We won't pattern match it. And the reason we'll do this is if the first argument is true, then the result of this is going to depend completely on the second argument. So if the second argument is true, we'll have true and true, which is true. And if the second argument is false, we'll have true and false, which is false. So we just return B in its stead here. So the first argument is true, then the result is just going to completely depend on the second argument. Now, we still have to cover the case of, well, what if the first argument is false? So we could use this wildcard character, which basically just means match anything, and don't even bother creating a name for this. And we'll say wildcard and wildcard, so anything and anything. And the idea here is if the first argument is true, okay, for the first thing we pattern match, well then if we ever get here, then this will be false. And if this is false, the whole thing is going to return false. So the crucial thing to realize about what's going on here is that the order matters. So when it goes through and pattern matches, it pattern matches this first thing first. So it says, can I fit this pattern first? If it can't fit this pattern, then it moves on to the second thing. So if we were to say, put this on top, well, then this function is just always going to return false. It'll never ever get to this scenario. It'll just say, can I pattern match to this first thing? And of course it can, because it matches every sort of scenario. It's just 2 wildcards here. Okay, it's just match anything, and then it returns false. So the order does matter. We need to make sure this one comes underneath. That's all you need to know about conditionals in Haskell for now. We'll cover more about pattern matching later, but until then, take care, guys.